Hi everyone. In this video, magpa-practice tayo ng material balances involving multiple unit processes na hindi reactive. So we will only consider yung mga physical processes in this example. So this example is actually a process called decaffeination by extraction. Okay. In other words, you have your the feed here is your coffee beans, and we want to decaffeinate yung ating coffee beans so that ang magiging desired end product natin in this example or in this process is yung ating decaffeinated coffee beans. Okay? So, ating mga decaffeinated coffee beans. Okay, so again, the feed in this process is meron ka ditong 100 gram of coffee beans. So, yung 100 gram of coffee beans mo na i-decaffeinate mo, malamang ang end product natin na decaffeinated coffee beans plus we will be able to extract yung caffeine na tinatawag. Okay? So what we could do here is to first visualize the whole problem. So I have here a few given information. So yung coffee bean natin, okay, ilalagay mo siya sa ating mixing tank. Okay? So ito yung mixing tank. So ano yung imimix mo with the coffee beans? So meron tayong tinatawag dito na solvent or DCS. So DCS stands for decaffeinating solvent. So yung decaffeinating solvent mo, kasi basically itong ginagawa nating extraction, tinatawag din natin siyang leaching. So si leaching, yun yung tinatawag nating solid liquid extraction. Okay? Kung saan you are extracting a solid component into a liquid phase. Okay? Basically, if you are, let's say, making coffee, so leaching yon kasi yung solids mo, okay, which is, let's say, you're using coffee powder, you are extracting yung caffeine doon sa powder or maybe even the coffee bean. So that's your leaching. That's your leaching process. So ganoon din yung basic na nangyayari dito sa ating process. It's just that we want to decaffeinate yung beans. Okay? So ang end product natin is number 1, coffee beans na wala ng caffeine, which is in this stream here. And number 2, yung ating caffeine na waste, okay? Which is probably here in this stream. So, ang nangyayari, yung solvent mo na DCS, so yung imimix mo dun sa coffee bean, okay? And because of that mixing, maalis nung DCS yung caffeine. Okay? So basically, ganun yung nangyayari. Now, here are a few given information. Okay? So number 1, each 100 gram of your coffee beans or 100 kilograms of your coffee beans contains 15 kilograms of caffeine. So ano ibig sabihin nun? Di ba meron tayo ditong 100 grams or 100 kilograms ng coffee beans. So kada 100 kilogram daw niyan, merong 15 kilogram na caffeine. So ang gagawin ko, isusulat ko na ngayon yung composition dito sa ating feed na 100 kilogram ng coffee beans. So ibig sabihin, 15 kilogram daw. Okay? Sorry, it's not 15, but rather I have here, let's change this to 1.5. Okay, so 1.5. Masyado palang marami yung 15. So 1.5 lang. Okay, so ilalagay natin yan ngayon dito sa ating feed composition. So sabi natin, 1.5 daw kilogram yung caffeine. So let me use caf na lang to shorten the word. And the rest is, of course, yung coffee bean solids, right? So 98.5, therefore, yung 98.5 kilogram of beans. Okay. Okay, so I hope you got that. So doon sa 100 kilogram coffee bean natin, 1.5 kilogram yung caffeine and 98.5 kilogram yung beans. Okay. Next is number 2, the solvent removes 90% of the caffeine in the coffee beans. Okay? Yung solvent daw na DCS, okay, it has the ability to remove 90% of the caffeine in the coffee beans. In other words, ang tinutukoy niyan, yung product natin dito na decaffeinated coffee beans, kung 90% ang na-remove na caffeine from the feed, therefore, we can say na 10%, okay, 10% yung natitirang caffeine dito sa decaffeinated part natin or decaffeinated coffee beans natin. So let me write that here, no? So again, 90% daw yung nare-remove na caffeine nung solvent. So ang matitira is 10%, right? So 10%, okay, times ilan ba yung caffeine natin dun sa feed? 'Di ba 1.5 kilogram caffeine? Okay? So ilan yan? Therefore, that will be equal to 0.15 kilogram caffeine here in this decaffeinated coffee beans stream. Okay? So 0.15 kilogram. Yung 90%, which is yung caffeine na na-remove ng solvent, ay mapupunta sa ibang part ng ating process. Okay? So yung 10% dito, yun lang yung natitira ng caffeine. Okay. Aside from the caffeine, syempre yung coffee bean na yan, alam natin dapat kung ilan yan. Kasi look, yung coffee beans natin, which is yung beans lang, right? Which is here, we say na 98.5 kilogram daw yung beans part lang, 98.5 kilogram beans. Malamang hindi naman siya mag-evaporate here in the dryer. Okay? So, therefore, at the end of the process, yung decaffeinated coffee beans mo, nandun pa rin yung beans part. Nawala lang yung caffeine. So, therefore, we can say na 98.5 kilogram pa rin yung beans dito sa stream na ito. Okay? Now, ano na lang ang kulang? Probably dito sa ating decaffeinated coffee beans na stream, baka meron pa dyang natitirang solvent. So, hindi naman siguro 100% efficient yung dryer natin. Okay? So, baka meron pa dyang solvent. So, aside from the caffeine and the coffee beans, okay, na walang caffeine, baka meron pa dyang solvent na natitira. Okay? Kasi ang nangyari dito, kapag minix mo yung solvent dun sa feed mo na coffee beans, okay, well, what happens is that, number 3, for each 100 kilogram of the coffee beans, 20 kilogram leaves with the coffee beans. Okay? 20 kilogram leaves with the coffee beans. So, ibig sabihin, meron ka daw 20 kilogram dito na DCS. Okay? Now, 90% of the DCS is removed through drying. Anong ibig sabihin yan? Di ba mayroon kang pinasok na DCS dun sa dryer? Kasi nga may coffee bean dyan. Gusto mong i-dry yung coffee bean with the DCS. Now, sabi dito sa number 3, 90% of the DCS is removed through drying. So in other words, this stream, okay, 90% of the DCS na pumapasok sa dryer, which is 20 kilogram. Okay? 20 kilogram DCS. That will be equal to 18 kilogram DCS. Okay? So yung 90% na yan ay nare-remove through drying. Okay? That's the purpose of drying, to remove the solvent. And it goes back to the mixing tank. Okay? It goes back to the mixing tank. Okay, so kung 20 kilogram yung ating DCS dito na pumapasok sa dryer kasama ng coffee bean, at 18 kilogram na lang yung nare-recover, kasi nga yan yung 90%. 18 kilogram na lang yung lumalabas sa dryer na babalik sa mixing tank. Eh di, alam natin kung ilan yung lumalabas na DCS dito sa stream na to, right? So ilan kaya yun? Kung 90% yung babalik sa mixing tank, therefore, 10% naman yung mapupunta dito sa decaffeinated coffee beans. So that answers our question. So in mathematical form, okay, so aside from the caffeine and the coffee beans, so meron daw, what, 10%, okay, na solvent ang mapupunta sa stream na to. So, gaano kadami yung solvent kanina? 20 kilogram. Okay? That basically is what? 2 kilogram DCS. Okay? Which makes sense, di ba? Kung 20 kilogram yung pinasok mo dito, 2 kilogram yung mapupunta dito, 18 dapat yung nandirito. So, it balances the masses or materials as far as the decaffeinating solvent is concerned. Okay? So, ano pa yung ibang information na kailangan natin consider dito? Number 4, the solvent entering the mixing tank is 95%. Okay, so how do we write that? Yung mixing tank daw, yung solvent na pumapasok sa kanya, okay, ay 95%. So let me kind of correct this one. So dapat, yung recycle stream kasi natin na yan, ay doon. No? Yan yung ating recycle stream. Okay. Now, yung fresh feed natin, malamang yung solvent na gagamitin natin, 100% yan na DCS. Pero ang tanong, ilang percent yung DCS dito sa mixed stream natin? So, sabi sa number 4, 95% daw. So, let me just kind of correct this diagram or rewrite lang para mas maayos siya. Okay. Yung recycle stream natin na hindi natin alam kung ano yung kanyang composition and yung amount. Okay. It recycles back mixing with the fresh feed. So yung fresh feed natin, it's actually not our main feed but our solvent. Okay. So yan yung recycle natin. And ang sabi sa number 4 ay 95% daw to. So this one is 95% DCS. Okay? Now, another thing is that the solvent entering the settling unit is 88%. So therefore, 88% DCS daw ito. Okay? And then, finally, the waste solution leaving the settling unit is 5% DCS, which is this one. Okay. Now, imagine, dito sa waste solution natin na 5% DCS, ano ba ang kanyang kasama? Tatlo lang naman yung component dito. May coffee bean, may DCS, at mayroong caffeine. Right? Yung coffee bean natin, ayun, nandun siya lahat sa stream na to. So this stream. Therefore, dito sa part na to, sa recycle, sa extraction unit, wala na siyang natitirang coffee bean. So kung 5% daw yung DCS dito sa stream na to, kung 5% daw yan, therefore, masasabi natin na 95% niyan ay what? Caffeine. Okay? Which makes sense, right? Kasi dinidecaffeinate natin yung coffee beans natin, may caffeine siya. So yung waste natin or yung undesired natin is tinatapon natin dito sa stream na to, which is dapat mas malaki yung porsyento ng caffeine. Okay? Ano pa ba? Well, we can also know na if this stream is 88% DCS, edi the remaining, which is 12%, siya naman yung caffeine. Okay? And ganoon din dito sa mixed stream na to. Kung 95% DCS yan, 5% dyan yung caffeine. Okay? So, I think we have put all together yung mga information dito sa ating diagram or ating flowchart. Probably we just have to name the streams, no? So let's say that the feed, which is yung ating 100 kilogram na coffee beans, tawagin natin siyang F. Tapos yung solvent, tawagin ko siyang L. Okay? Parang liquid, ganun. Tapos M itong mix part or mix solution here, which is entering the mixing tank. The recycled stream, we call it R. Let's call this stream P. Okay? Ano pa ba? We can use W to denote the waste stream. And here, yung decaffeinated coffee beans natin, tawagin natin siyang stream D. Okay. So now, let's start with the material balance. But before that, of course, ito yung mga hinahanap. Number one, we have to calculate how much solvent is used. Ang tinutukoy natin dyan is therefore yung L. And number two, composition of the recycled stream. So yung R, hanapin natin kung gaano kadami yung R, at the same time, kung ano yung composition ni R. We know for a fact already na si R, meron siyang DCS, meron siyang caffeine. Okay, pero ano yung percentage nung dalawang yun? Okay, so let's start with the balance. Okay, what will be a good basis for this particular process? So I will make a basis since given naman na meron kang 100 kilogram na coffee beans with the caffeine, of course, intact. So 100 kilogram coffee beans. Okay. Now, let's perform first, diba, yung tinatawag nating overall balance around the whole system. Okay? As if you are considering the whole system as a single unit. So, pag kinonsider mo yung whole system natin as a single unit, pinagsama-sama mo si mixing tank, si dryer, si extraction unit, therefore, ang mga pumapasok lang na materials doon sa considered single unit, which is the entire process, ay ang mga sumusunod, di ba? Yung F, yung L, okay? Ano pa? Yung D, yung W, sila naman yung lumalabas. Ang pumapasok lang ng F and L, ang lumalabas ay D and W. So sina R, sina M, sina P, they're within the system already. So if you're considering the whole system as a single unit, ang lumalabas, F and L yung input, D and W output. Okay? So therefore, we can write that as mathematically as what? Let's write it as F plus L. Okay? Feed plus the solvent equals yung decaffeinated coffee beans natin, D, plus yung waste stream na containing yung caffeine natin. Okay? Now, we know that F is equal to 100 kilogram. So 100 plus L equals D plus W. Okay? So at this point, meron tayong tatlong unknown agad. So we can probably go with system component balance next. System component balance. Okay? So again, we're considering still the whole system as a single unit. We already provided here yung ating overall. But how about the components? So let's check with the coffee bean balance. So coffee bean balance. Ibig sabihin ng coffee bean yung wala ng caffeine. Okay? So can we do that yung coffee bean balance natin? Okay. Meron tayong coffee bean, of course, dito sa F, which is 98.5, right? Sa L, wala kang coffee bean kasi purely 100% DCS yan. Sa D naman, ayun, meron kang coffee bean. Sa W, wala kang coffee bean. Okay? Wala kang coffee bean. So therefore, yung ating kapag nag-perform kayo ng coffee bean balance, hindi na siya mahalaga. Okay? Wala na siyang bearing kasi known na siya. Kumbaga, fully solved, fully known na yung amount ng coffee bean natin sa F, sa L, sa D, and sa W. Okay? So, hindi siya mahalaga for now. Therefore, let's go to the next component. So, ano bang po pwedeng gawin? After coffee beans balance, maybe we can have the caffeine balance. Okay, caffeine balance. Okay, so paano yung caffeine balance? So, caffeine balance is caffeine in F plus caffeine in L equals caffeine in D plus caffeine in W. Okay? But how much is the caffeine in F? Alam natin yun, di ba? Caffeine in F is 1.5 kilogram. Kasi remember, you have 100 kilogram of coffee beans with the caffeine. 1.5 kilogram yung caffeine. Now, caffeine in L is 0. So, wala siya. Okay? Now, caffeine in D, well, do we have that? May caffeine ba sa D? Kung babalikan natin yung diagram natin, yes, it's actually 95% of W. Okay? I'm sorry, W pala, hindi D, 95% yung ating caffeine. So, consider mo natin yung D pala. No? Ito yung D pala. Here, this is D. So, ilan daw yung caffeine dyan? Alam na natin yung kanina, which is, ayun no, 1.5 kilogram. So, not 1.5, 0.15 kilogram. Okay? So, let me double check. Yan, 0.15 kilogram. And then lastly, yung caffeine sa W, ito yung sinasabi ko kanina na 95% of W. Okay, now look at this equation. Ang unknown mo na lang dito ay W, right? So therefore, we can solve for W. W therefore is equal to, solving for it, 1.421 kilogram. Okay, and let's highlight this. We probably use okay. Now, hindi naman si W ang hinahanap eh. Pero maybe mahalaga yan mamaya, right? So after we perform the overall system balance, both sa overall and sa component, ang gawin naman natin is we will consider portions of the system or maybe some individual unit operations. Pero before that, since meron na tayong W, ibalik natin siya dun sa, okay, so let me write it this way. So yung W na yan, substitute natin okay, in system overall balance. So ano nga ulit yun, di ba? F plus L equals D plus W. F is 100. Okay. Plus L, hindi pa natin alam. D, wala pa. Pero si W, ito na yung na-solve natin na 1.421. Okay, so L and D unknown pa rin. Pero teka lang, di ba si D, we will go to the diagram here, eh alam na natin kung gaano kadami si caffeine. Alam na rin natin kung gaano karami yung coffee bean. Alam na rin naman natin kung gaano karami yung DCS. Iyan lang naman yung tatlong component doon sa ating stream, sa ating system. So if you add all these streams or all these amounts in that stream D, therefore we will be able to get the amount of D. So let's write that down. Okay, so consider the dryer, or consider stream D rather, no? Consider, okay, D. So D is just the sum of the coffee beans, the caffeine, and the DCS. So we have 98.5 kilogram na coffee bean plus 0.15 kilogram na caffeine plus yung ating DCS daw dun sa ating flowchart. Okay, sa stream D is 2 kilogram yung DCS. So totally, meron tayong 100.65 na kilogram. Okay, na D. Okay? So highlighting that, na-solve na rin natin therefore. Not really solve pero kasi known siya dun sa ating information. So meron na tayong D, meron na tayong W, meron tayong F kanina, o di masosolve na natin pala yung L. So if you go back to this equation here, okay, again, 100 plus L equals D, which is 100.65, kakasolve lang natin, plus 1.421. Therefore, L is equal to 2.071 kilogram. And therefore, nahanap na natin sa wakas yung ating L or yung amount ng DCS or yung solvent natin. Okay. So there. Remember, ang hinahanap dito sa ating problem is si L tsaka yung composition ni R. So we're done with letter A pretty much. Okay? So, para malaman natin, ma-solve natin yung R, so let's get to it. Ibig sabihin, let's consider other balances, no? So, consider kaya natin yung dryer. Okay. So, consider the dryer. So, ang ginagawa ko ngayon is, iniisa-isa ko yung mga equipment or mga unit operations. So, dryer, baka may ma-solve tayong material balance dito sa dryer na to. So, let's see. Balik natin sa flowchart. Ito yung dryer. So, si dryer, well, if we're going to check, meron na tayong na-solve na 18 kilogram na DCS, leaving it. Tama? And in the other outlet, alam na rin natin na ito yung composition ni D. Okay? So this stream is okay already. We have known the amount and the composition. This stream is also okay already. And itong stream na to, ganun din. Okay? 20 kilogram DCS, of course, hindi pa kasama dyan yung coffee bean na sumasama doon sa stream na yan. Okay? But essentially, we have solved that equipment or that unit operation. So, sa ngayon, hindi pa natin mako-consider yung dryer. Ibig sabihin, tapos na kasi all streams are known already, therefore, wala tayong mapapala. So, what else can we consider? Well, we want to perhaps consider yung stream inlet to the dryer, which is this one, right? So if I may change this, ito yung inlet sa dryer natin, 20 kilogram DCS. 20 kilogram lang ba yung pumapasok dyan? Siyempre hindi. Kasama na dyan yung coffee beans na 98.5 kilogram. Ano pa ba? Tsaka siyempre yung 0.15 kilogram na coffee. So in this stream here, so let me write. So bukod sa 20 kilogram na DCS, Okay, let me write it here. Meron kang 98.5 kilogram beans. Bakit 98.5 kilogram? Kasi yan yung na-recover natin dito di ba? Tapos meron kang 0.15 kilogram na caffeine. Kasi alam natin na 0.15 kilogram yung caffeine dito, edi ibig sabihin 0.15 kilogram din yung nandyan. Kung ano yung pumasok siya lang yung lumabas na caffeine, right? Wala namang caffeine dito sa part na to. The rest of the caffeine, of course, goes to this stream P. Okay, therefore, we can actually now add all these components, and therefore, this inlet stream, which we haven't really named yet or symbolized. So, sabi nating H. Okay, so this is your H stream. So if we're going to add all of that, okay, so H will be equal to, di ba meron tayong 98.5 na coffee beans plus 0.15 na caffeine plus yung 20 kilogram na solvent. It will be equal to 118.65 kilogram. Now, balik tayo dito sa dryer. Gaya ng sinabi ko kanina, sa dryer, all streams are known already. So, wala tayong napala sa dryer. Okay, so wala tayong magagawa kundi i-consider yung ibang streams or units. How about yung mixing point kaya? Consider the mixing point. Ano ba yung nasa mixing point? Well, in your mixing point, meron kang fresh solvent, tapos i-add mo dun yung recycle. So you can refer to the diagram later. And then, that will be equal to the mix feed, okay, or mixing point. Now, do we have the value for L? So we have solved that earlier. That's 2.071. Pero si R wala pa. Si M wala din. Now, what if I perform a DCS balance at the mixing point? Now, ilan yung DCS sa L? Di 2.071 din. Kasi 100% ng L DCS naman yan Plus DCS in R. This is a recycle stream, which we don't know yet. Okay, equals, sa mixing point, alam natin kung gaano kadaming or percentage or composition ng DCS doon sa mixing point. That's 95%, di ba? 0.95 of M. So let me illustrate, let me show you that, no? Para hindi kayo maligaw. Medyo malayo. But ito siya. Ito yung mixing point natin. 95% daw yung DCS. Okay? So if you combine R and L, it will give you M. So yun yung pagkakasulat kay material balance. Okay. Pero ganun pa rin, wala tayo na pala. Di consider tayo ng ibang unit operation. Consider extraction unit. Okay, so sa extraction, di ba, meron tayong product coming from the mixing tank. And ang outlet niya is yung waste stream plus yung recycle stream. Tama ba? Well, we don't know P, we don't know, well, we know W, but we don't know R. Okay, so we have two unknowns here. Okay, so wala tayong napala sa overall balance sa extraction unit. How about DCS balance, DCS at extraction unit. So what I'm doing here is really going through each unit one by one and going through each component as if possible one by one hanggang sa may mapala ako na. So if we perform DCS balance at the extraction unit, okay, do we have the composition of DCS in P? Meron tayo niyan. 0.88 of P is DCS equals 0.05 of W. Okay, kasi 5% daw yung DCS of W, right? If you recall. Plus DCS in your R. Eh kaso isa na namang unknown yung DCS in R. Tama? So, well, ganoon pa rin. Wala tayong nakuha sa balance na yan. Yung mixing tank kayang i-consider natin. Consider the mixing tank. Okay, so ano ba yung nandun sa mixing tank? 'Di ba, meron tayong pinapasok na F, 100 kg na coffee bean, plus M, okay, plus 18. So later on, papakita ko kung bakit yan. Equals 118.65 plus P. Okay, bakit? So if you go to your mixing tank, F yung pumapasok, di ba? So ito yung F. Mixing tank lang ha. And then yung pumapasok sa mixing tank ay M. Not L ha, but immediately ang pumapasok sa kanya is M. Okay? Plus, ano pa yung pumapasok? Ito, 18 kilogram. Okay, 18 kilogram pumapasok din sa kanya. That's why I have written here 18 kilogram. Ano naman yung lumalabas? P tsaka 118.65. So let's prove that. Lumalabas ay P, which is this one. And yung 118.65, which is yung H natin. Okay? So that will be our mixing tank balance. Okay. And if you notice, dalawa lang ang unknown dito, which is M and P. So let me rewrite the equation. M minus P becomes 0.65 if you are going to simplify the equation. Let me consider this as equation 1. Okay. Now, after doing the overall balance around the mixing tank, let's perform DCS balance around the mixing tank. Okay, so DCS in F, ilan yun? I'm sorry, DCS in... Tama, DCS in F, meron ba? Wala, di ba? 0. Plus, DCS in M, alam natin na 95%, di ba? 9.95 M. Plus DCS, or plus 18, so ito pala, plus 18, equals, bakit plus 18? Kasi yung buong 18 kilogram na yan na pumapasok sa mixing tank ay purong solvent. Okay? Equals DCS in H. This is actually H, right? But the DCS in H is just 20 kilogram. Tama? The rest is yung coffee beans and the caffeine. So 20 kilogram lang. If you will refer to the diagram and to the information given, so that's 20 kilogram. And lastly, sa P naman, ang DCS dyan ay 0.88%. Okay? So 88% pala. Not 0.88%, but 88%. So simplifying the equation, we'll get 0.95 m minus 0.88 p equals 2. This will be your equation 2. Okay? So you have now two equations and two unknowns. Therefore, you can solve this equation simultaneously. You'll get m equals 20.4 kilogram and p equals 19.75 kilogram. And itong mga to, well, hindi pa ito really yung mga sagot sa ating problem. Okay? But maybe we will need that. So moving on, let's consider balik natin yung extraction unit. Pwede rin mixing point. You can perform mixing point balance also in this one. But in the extraction unit, remember it's P equals W plus R. Okay? So nasan yan? Di ba? Kanina ginawa natin yan. This one, right? Now, we already know P, 19.75. We already know W, kanina pa yon, which is 1.421. So ang wala na lang, ang ano na lang dito ay R. So therefore R, we can solve it to be 18.33 kilogram. Ayun. Pero hindi naman yung tinatanong. Tinatanong dito yung composition ni R, kung ilang percent si DCS, ilang percent si caffeine. Well, we can probably perform DCS balance again around the extraction unit. Hopefully, maging successful na tong DCS balance na to. Kanina hindi tayo wala tayong napala. Pero ngayon baka meron na kasi meron na tayong additional derived or solved values. Okay, so DCS balance in the extraction unit. Remember that ang DCS kay P ay 88%. So 0.88 times P. Ano ba yung P? 19.75. About sa W, ilan yung DCS dyan? Di ba 5%? 0.05 of W. Ilan ba yung W? 1.421. Ano ba? Plus sa R, DCS and R, we don't know. Which is unknown actually, DCS in R. O di isa na lang unknown, DCS in R na lang. Which is, if you solve 17.31 kilogram. Okay? So ang kulang na lang sa R, alam natin yung DCS sa kanya, si caffeine na lang. O di mag-caffeine balance tayo. Caffeine balance at the extraction unit. Okay, so ilan ba yung caffeine sa, diba, remember, ito yung ating extraction balance overall. Ilan yung caffeine sa P? Eh, di ba 12%? Kasi 88% yung solvent eh. So 0.12 of P, and P again is 19.75, right? Equals caffeine in W. Eh, 5% kanina yung DCS, so 95% yung caffeine. So 95% of W, and W again is 1.41. Plus, sa R, caffeine in R, unknown. Yun yung hinahanap natin. Therefore, caffeine in R, you will be able to solve that to be 1.02 kilogram. Okay, so you now know already yung caffeine sa R, alam niyo na rin yung DCS sa R. So let's summarize that. our composition. We have, again, 17.31 kilogram of DCS and 1.02 kilogram of caffeine. If you add these two, you will get 18.33 kilogram of R, which is consistent siya dun sa na-solve natin na R kanina. Okay? So how about the percent of each? So 17.31 divided by 18.33, that's 94.4%. And yung 1.02 divided by 18.33, or maybe 100% minus 94.44, yun yung siya natitira. 5.6% naman yung caffeine. So therefore, this is now the final answer. Okay? This is now the composition of your recycle stream.